Right. The show has started. So the first thing you're given here is that x and y are in the second quadrant. So on the unit circle, number one on your exam, which is I think next week, it was number one question: make the entire unit circle. Number two question will be to put all your little tangent x equals sine x over. I want those on the first 2 pages, and then you can rip off those first 2 pages and use on the rest of your exam. So the unit circle, you're in the second quadrant. This is quadrant 1, this is quadrant 2. So here, cosine is negative, because the x's are negative, and the y, the signs, are positive, because the elevator's going up. So that gives you the sign, and that's why they gave you this information, x and y in the second quadrant. You're given sine x, and you're given cosine y.
Don't you mean sine is, wait.
Positive, second quadrant.
No, because you put cosine is x and sine is y, but over here you put sine is x and cosine is y.
It doesn't matter. In this quadrant, all the cosine values are negative, and all the sine values are positive. It doesn't matter. In this quadrant, that's the rule. The x coordinate are all negative, and the y. You hear some teachers go like this, right? So the cosine y is negative, and the sine x is negative too. You're going to need them all, positive. You're going to need them all. Because if you go to the table of formulas I gave you.
Is that x and y both negative, or right?
No, the x coordinate is always negative, and the y coordinate is always positive. The sine is always the y coordinate, and the cosine is always the negative the x coordinate. So that's all you have to remember. Then you look in your table of formulas, which you got because it's not that one that I command, right? If it's something I know, you got to know it. If it's something I can't pull it off, then it comes on there. And you have it. They want you to find sine of x plus y. Some person decided to put Greek letters in this thing, but the formula that you're going to grab is this one. So that's the formula. And then you've got x's and y's, so you don't want alphas and betas. So you're really going to have this one. And I'm only rewriting it because if I was using my laptop, I would just erase the alpha and the beta and replace it with x and y. I'm only doing this because it's on the blackboard. So you were asking about cosine x and sine y. Why do I have them? Because they're here. They're in the formula. I need them. So what do I have? What's given to me? I know this and I know this. They gave it to me. I know these two values because they gave it. But I don't know cosine x and I don't know sine y. There's 2 ways you could get it. You could use Pythagorean's theorem, or you could use triangles, opposite over adjacent. So I think I've shown you both ways. So to find cosine x, because I don't know it, I need that number to plug in the formula. To find cosine x, well, I have sine x. I know sine squared plus cosine squared is equal to 1. Me, slow down? I don't think I can do that.
I'm like trying to write the steps before, and then you're on to the next one. I'm trying to catch up.
I told you this is a problem. It's almost better if it's on the laptop. I just get so excited. What's the most famous identity, Jen?
Sine squared x plus cosine.
Squared x equal 1. Should be a song. Should be your song, your ringtone. See, I'm giving you new ideas to improve your social standing, and none of you are taking it. The unit circle tattoo, don't see it. Ringtones that are the most famous identity, don't see it.
Why are you finding cosine of x and not sine of y?
Because they're missing. These 2 numbers I have, so I just plug them in down here, but these 2 numbers I don't have, so I need to find them.
Why does it matter which one you find first?
No. They're equally as nasty. Okay? So I'm going to find cosine x because it happened to be first. Okay, cosine x most famous identity, I know cosine squared x plus sine squared x is equal to 1. But I know sine x, it's 1/4. So I can pop the 1/4 in for the sine x. So all I did is I took the sine x and I replaced it in here. Sine x squared is 1/16. So I have to take this sine x and square it. I don't think I'm going to use the board again.
I like when you put that.
Yeah.
Yeah, but we can't, you know, one thing I saw is like if you're writing something down wrong from the board, that's on your still frame. With the laptop, it won't ever happen like that. And then I can use colors to show you where each one of the numbers are coming from. I can also see the number of hits on the YouTube videos. You're not looking at them again. They're actually really good. I spend a lot of times trying to show you where things came from.
I think this one needs you like write each step out.
That only helps you in class. It doesn't help you outside of class. That's the problem.
And then in class will help us.
We can do a mix, right? So I have all the material up already on YouTube, so you can go back and watch it. And then we could do this once in a while. And maybe if the recordings come out right, then you can go back and look at the recordings. Let's see. I haven't watched it yet. Okay, I don't want to keep, let me erase up to here. Okay, so cosine squared x is 1/16 plus 1, so I can solve for cosine squared x. It's 1 minus 1/16. That's 16 over 16 minus 1/16, which is 15/16. That's right, square root. By the way, what will be the sign of this do I put a plus or minus? Negative, because they told me right away that the cosines were negative because it's in the second quadrant. So this is a negative. So this is equal to square root of negative 15 over 4 because I can square root the 16. Square root of 16 is 4. So I got that. That's cosine x. Annoyed yet? Because you have to do the same thing with the sine. Same thing with sine y. You know that sine squared y plus cosine squared y is equal to 1 because it's going to become Jen's ringtone. You would have the most unusual one. Okay, so sine squared, what's the cosine of y? That's given to you at the beginning and I've already erased it. Minus 4/5. This is why I can't find my keys, because I've got stuff like that in my head. Sine squared y plus, was it minus 4/5?
Yeah.
So this was given. So sine squared y is equal to 1 minus 16 over 25. And where did that come from? That's 4 squared over 5 squared. Sarah?
Sine squared y plus cos squared y plus
Sine squared theta plus cosine squared theta is 1. Sine squared alpha plus cosine squared alpha is 1. Whatever it is, it doesn't matter what's in there. Sine squared Sarah plus cosine squared Sarah is equal to 1.
But how come you don't have an x?
Because I need the y. If you go back and look at the formula, the missing pieces I needed were cosine x and sine y. Right? If you see the question marks above my I erased it. That's why I need I'm looking for the y. Okay, so then I get this is equal to 25 25ths minus 16 25ths. Have you noticed the pattern in the WebAssign problems? They always give you one crappy number and one nice number. There's one that has a square root in it. You start seeing the pattern in their problems. 25 minus 16 is 9. So then square root both sides. Plus or minus? Plus or minus for the sign? Plus, because they told me it was in the second quadrant and signs are positive. See, one of them's nice without square roots and one of them's not nice. And I know that because I've done 3 or 4 of them now. Have you done 3 or 4 of them? You should, because I already know it. I shouldn't have to do more problems than you. You should have to do more than me. And I didn't find it pleasant the first time around. All right, so we got that.
Is there anything else to do?
Yes, we got to plug it back into the formula. Okay, formula said sine of x plus y is sine, I always get the x's and y's mixed up. Sine x cosine y plus sine cosine x. Sine y, now I can fill in all the numbers. Sine x was, I forgot it already. Hmm?
Sin x, yeah, 1/4.
1/4. Cosine y was scary. No, cosine y was not, minus 4/5. Plus cosine x was scary, square root of 15 over 4. And sine y is, we just did that, right? 3/5. And I don't care. I don't care what goes here at this point. You get up to that point, you've got full credit. I don't really care if you can add and subtract numbers. Good? Every step of this, I believe that every single one of you can do it. I've already seen your work. Every one of you is smart enough to do that. So it's just putting it all together.